Multiplying and dividing radicals. When we're multiplying radicals, the first rule that we're going to talk about is the product rule. And we've already talked about this a little bit. So you know that the square root of a times the square root of b are real numbers. Then we can multiply these together. Keep in mind that when you add and subtract, you've got to have like radicals. But when you multiply, you can multiply anything you want. And we used this rule when we were rationalizing radicals back in 15.2. So here, multiply and then simplify the product if possible. Well, if we have the square root of 7 times the square root of 5, so as long as the indices are the same, we can multiply these together. So since we're taking the square root of both of these, we're going to have the square root of 35. And then you have to think, is there a perfect square that will go into 35? And there's not, so this is reduced as far as it'll, or simplified as far as it'll go. Now, letter B, you have the square root of 3 times the square root of 15, which will go into the square root of 45. Well, that one will simplify because we have the square root of 9 times the square root of 5. And then the square root of 9 is 3, and you can't do anything with the square root of 5. So make sure you check and see if it will simplify once you multiply. Alright, what about with variables? Same thing. We're going to multiply the square root of 3y times the square root of 5x. Both of these have the same indices, so we can multiply these, and we're going to get the square root of 15. 3 times 5 is 15, and then x times y is xy. And that won't simplify because there's not a perfect square that'll go into 15. So here, this should look familiar to you. It's the distributive property. So what we're going to do is we're going to take what's outside and multiply times what's inside. So the square root of 3 times the square root of 3 is the square root of 9, minus the square root of 3 times the square root of 2 is going to be the square root of 6. Notice the square root of 9 will break down to 3, minus, pay attention to what the sign in between, and the square root of 6 won't break down. So we learned earlier how to add and subtract radicals, and we know that we can't put these together because this is a whole number and this is a radical. In order to put radicals together, you have to have like radicals. So up here, when we have a monomial times a binomial, we're just going to use the distributive property. Here, when you have a binomial times a binomial, most of you say that that's the full method, so that's okay. That's what we'll go with. So we're going to take the square root of 3 and multiply it times both of these in the second group. So the square root of 3 times square root of 3 is going to be the square root of 9. And then the square root of 3 times 8 is going to be a positive 8 square root of 3. Remember, you cannot multiply whole numbers times radicals, so you just get 8 times the square root of 3. Then we'll take this negative 8 and multiply it times both of these in this second group. So negative 8 times the square root of 3 is going to be negative 8 square roots of 3. And then negative 8 times 8 is going to be negative 64. Now, in the middle, we have like terms, or like radicals, so when we put those together, negative 8 is going to go away. They're going to go to 0. The square root of 9 is going to be 3, and then we have a minus 64. And then we can put that together, of course. 3 minus 64 is going to be negative 61. Alright, so our quotient rule for radicals, if you have the square root of a and square root of b, and they're real numbers, then the square root of a over the square root of b can be written this way. So if you have a fraction under the radical, we can break them apart. And if we have a radical divided by a radical, we can also put them together. So these are interchangeable, and don't forget that. And this, just remember, your denominator cannot be 0. Okay, so if I have the square root of 14 over the square root of 7, I know that 14 and 7 will reduce. So what I would like to do is I would like to put these back together, square root of 14 over 7, and reduce 7 going to 14 2 times, and so we get the square root of 2. And you cannot simplify the square root of 2. Same thing with letter B. If I put these back under one radical, I get 100 over 5, which is going to be the square root of. Now, I'm not taking the square root of anything, so you can't get rid of the radical unless you've actually taken the square root of some number. And so if you do 105, we'll reduce to the square root of 20. But the square root of 20 will break down. Remember, that'll go into 4 times 5, and then the square root of 4 is 2 times the square root of 5, which won't break down. So what about our variables? Same thing. I noticed that the a's will reduce and the b's will reduce. So if I put this back underneath one radical, I know that 3 of these will take out 3 of those, leaving us with 4. And then these two will take out 2 of those, leaving us with 4. And then to take the square root of this, the square root of a to the fourth is a to the second, and the square root of b to the fourth is b to the second. So remember, when I go from here to here, I'm not taking the square root of anything, I'm just reducing what's underneath. But here to here, I am taking the square root, and so the square root symbol goes away. So make sure you pay attention. When do I need the square root and when do I not need the square root? Alright, rationalizing denominators. Many times it is helpful to rewrite a radical quotient with the radical confined to only the numerator. If we rewrite the expression so that there is no radical in the denominator, it is called rationalizing the denominator. This process involves multiplying the quotient by a form of 1, and we did this back in chapter 14, that will eliminate the radical in the denominator. So, here, when we rationalize, and when it says rationalize the denominator, what we want to do is we want to get rid of the square root, the radical symbol, in the denominator. And to do that, we need to multiply by a fraction that is equivalent to 1. So in other words, we're going to multiply the top and the bottom by the exact same thing. So what is that thing? Well, remember the perfect square list that we made way early in the chapter? I want to know what I can multiply 2 by in order to get me on that square list. In other words, 2 times what number makes a perfect square? And the answer is 2. So the square root of 2 times the square root of 2, and remember, you have to multiply it by the square root because you can't multiply the square root of 2 times 2. That's just 2 radical 2, and that's not doing anything. You have to multiply the top and the bottom by a square root that's going to give me a perfect square on the bottom. So watch what happens. Square root of 3 times square root of 2 is going to be the square root of 6. Square root of 2 times square root of 2 is going to be the square root of 4. Don't reduce this, because if you reduce, it's going to take you right back here. Instead, simplify. Don't reduce, but simplify. So the square root of 6 doesn't have a perfect square in it. It has to stay the same. But the square root of 4 is just 2. Now, from here to here, we simplified. And so now you may think, oh, well, now I can reduce. The 2 will go into the 6 3 times. But you cannot do that. So for the same reason, if I asked you, what is 2 times the square root of 3? I would hope that you would tell me 2 square roots of 3, because you cannot multiply a whole number times a radical. Well, same thing. You can't divide a radical by a whole number either. So you have to leave it like this. Alright, so let's go here. Rationalize the denominator. So what I need to do is I need to simplify first. And remember, you can simplify at the beginning and you can simplify at the end, but never reduce. You can reduce at the beginning and reduce at the end, but never in between. So watch this. I can break this 45 down. And the reason I want to do that is because I don't want to deal with such a big number. So I know that 45 will go into the square root of 9 times the square root of 5, and of course the square root of x. I can't do anything with that either. So what I'm going to have is the square root of 2 over the square root of 9 is going to be 3 square roots of 5x. So what I did is I took my division and I broke it into the fraction. Remember, I told you these are interchangeable. We can go either way we want to. Well, since I have a fraction under here that won't reduce, it would be beneficial to go ahead and break it into the top and the bottom, a numerator and denominator, the square root of the numerator and the square root of the denominator. Then the denominator would break down even farther. And the reason I did that is because I didn't want to multiply to make this a bigger number, because it's a pretty big number as is. Not to mention the fact I would have to multiply it by something to give me a perfect square, and that perfect square is going to be really big. So what I had rather do is I had rather simplify it as much as I could, and now I can multiply 5x times a number to get me on that perfect square. So 5 times 5 is 25, and x times x is x squared. So I'm going to multiply the top and the bottom by the square root of 5x. Now, on top, I have a radical times a radical, and I can do that. So that's going to be the square root of 10x. On bottom, I have a whole number here. I cannot include that in the multiplication, but I can multiply the square root of 5x times the square root of 5x, and I'm going to get the square root of 25x squared. Alright, so now I'm going to simplify. So I can't do anything with the square root of 10x. That has to stay as is. But on the bottom, I have 3 times. The square root of 25 is going to be 5, and the square root of x squared is going to be x. So now I have the square root of 10x over 15x. And again, I cannot reduce a radical with a whole number. So this is my answer. Okay, conjugates. So we worked a conjugate a while ago. I just didn't say anything about it. Let me show you. Here. Letter B. This is a conjugate. So it looks like what we called a sum and difference back when we were doing the multiplication. So anytime you multiply a sum and difference, the middle two terms are going to cancel out, leaving you with things that you can do for the first one and for the last one. But the main thing to remember is these two are going to cancel out. The middle two will always cancel out when you have a sum and difference. Well, when we talk about radicals, they're called conjugates. It's not called a sum and difference, it's called a conjugate. So a conjugate looks exactly the same, except one's a negative and one's a positive, or vice versa. So let's look at here. Many rational quotients have a sum or difference of terms in the denominator rather than a single radical. That is important for you to know, because if you have a single radical in the denominator that you need to get rid of, you're just going to do this process. You're going to rationalize the denominator. However, if you have a plus sign or a minus sign in the denominator, you've got to use conjugates. So that statement right there is extremely important for you to remember. If you have a plus or minus in the denominator and you do need to use conjugates, in that case we need to multiply by the conjugate of the numerator or denominator, whichever one we're trying to rationalize. And the conjugate uses the same terms but the opposite operation. So if I have x plus 3, I'm going to do x minus 3. That's the conjugate. So look at this one. Notice there's a plus sign here, which means I can't just multiply the top and the bottom by the square root of 7. I have to multiply by the conjugate of 2 plus square root of 7. And the conjugate of 2 plus square root of 7 is 2 minus the square root of 7. And I have to do this on the top and bottom. I have to multiply by the conjugate on the top and the bottom. Okay, so on top I have a single term multiplied by two terms. That's your distributive property. So 3 times 2 is 6. We've been doing that since kindergarten. And 3 times negative 1 radical 7 is negative 3 radical 7. You cannot multiply a whole number times a radical. This is a decimal, so you cannot multiply those. Okay, now on the bottom, we do have a sum and difference, but remember what I told you, the middle two terms are going to go away. So if you full this out, the middle two terms are going to go away. So all you have to do when you multiply by the conjugate on the denominator only is the first times the first and the last times the last. So we're going to have 2 times 2, which is going to give me 4. And the square root of 7 times negative square root of 7 is negative square root of 49. Okay, so let's simplify this. 6 minus 3 square roots of 7 over 4 minus the square root of 49 is going to be 7. So let's keep going. 6 minus 3 square roots of 7 over 4 minus 7 is going to be negative 3. Now, all three of these will reduce by 3, and so that's what I'm going to do. So 3 will go into 6 2 times, 3 will go into negative 3 negative 1 time, and 3 will go into negative 3 negative 1 time. So what I'm going to do though is I'm going to take this negative 1, I'm going to go here and here. So what I'm going to have is negative 2 plus the square root of 7. Reason being is because I have 2 minus 1 square roots of 7. Well, 2 divided by negative 1 is negative 2, and negative 1 divided by negative 1 is positive 1 square roots of 7. You can write the 1 if you want to, you just don't have to. Now, something else that's important. Notice that I did not reduce until the very end. If you go in here and you reduce the 6 and the 4, number one, you're breaking algebraic rules because you have a binomial over a binomial. They're groups, and we learned that in the last chapter. You cannot reduce parts of groups. You have to reduce the whole entire group. So instead what I did is I just simplified the square root of 49 and got 7, and then I could combine the denominator into 3. And the reason that I could reduce this is because all 3 of these whole numbers would reduce. If all 3 whole numbers don't reduce, you cannot reduce that. So let's try this again. Rationalize the denominator. Notice I have a plus sign here. So I'm going to multiply by the conjugate, which is the square root of 2 minus the square root of 3, top and bottom. Alright, on the top I have a binomial times a binomial. That's your full method. Alright, so I'm going to do square root of 3 times the square root of 2, which is going to be the square root of 6. Square root of 3 times negative square root of 3 is going to be negative square root of 9. 2 times the square root of 2, that's a whole number, times a radical. You cannot do that, so we're just going to write what we see, 2 square roots of 2. And then 2 times negative square roots of 3 is going to be negative 2 square roots of 3. Alright, let's see what we can do on the bottom. For the bottom, it's the full method again, but since it's a conjugate, anytime you multiply conjugates, the middle 2 terms are going to go away. So let's do first times first. Square root of 2 times square root of 2 is going to be the square root of 4. And last times last. Square root of 3 times square root, negative square root of 3 is going to be negative square root of 9. Okay, let's simplify where we can. Simplify, not reduce. Simplify where we can. Can't do anything with the square root of 6, so we're going to have to leave that. Minus the square root of 9 is just 3. And then 2 square roots of 2, can't do anything there. And minus 2 square roots of 3, can't do anything there. And then on the bottom, the square root of 4 is going to be 2 minus the square root of 9, which is going to be 3. So what we're going to have here is a negative 1. So we have the square root of 6 minus 3 plus 2 square roots of 2 minus 2 square roots of 3. And you cannot put any of that together. None of them are like radicals, and then you have your whole numbers, so you can't put any of that together. And then on the bottom, we have a negative 1 again. I don't like that negative 1 on the bottom, so what I'm going to do is I'm going to do minus the square root of 6 plus 3 minus 2 radical 2 plus 2 radical 3. So you're just going to change all those signs to get rid of that negative 1. And again, you cannot put any of these together because these are not like radicals, and you have a whole number. You cannot add those together.